afternoon. So today it's supposed to be presented by two people. I'm sorry, there's only one here. But today I'm going to be presenting fine-grained composable scoping, tying UI and data lifecycles at the compilation stage. It's going to be presented by me, Mathan Raj. I work at TikTok for the mobile arc and infra team. I have total of 11 years of experience and 6+ years of experience in improving developer experience. And today I'm going to be first going through what's the topic about, and then some background on the screen building at TikTok. And we will move on to what Compose is lacking, which is scope. And then we will see how we are going to build that by maintaining state and lifecycle in a better way. And finally, we'll be using KCP to wire this entire thing at compile time so that we make it simpler. So let's jump in. So first of all, the title fine-grained composable scoping doesn't clearly explain what it does, maybe a bit more complex. Maybe let's try to break it down, right? Scoping. To understand scoping, we need to understand scope. Simple definition can be a scope makes an object exist only for as long as its activity or fragment does. Again, maybe a bit vague. So maybe let's just take an example, right? So let's say this is the checkout screen of the TikTok app. You have checked out items and also recommended items, and then you have a total price and also the place order. Let's say this is built by the e-commerce team, and probably let's say there is only small number of developers who started building the screen. Probably they would start with something like this. There is activity, and there are a couple of recycle views, text views, and everything, right? And again, all the examples that I'm going to be presenting today are representative examples and not real at TikTok. So let's say this is the structure looks like, and the state maintenance for this would probably done at the view model level. Let's say there's a checkout view model that has some substates like checkout items, order total, and recommended items, right? So this view model, which is holding the state, will live only as long as this activity lives, right? When the activity gets created, the view model is created. When the activity is destroyed, the view model gets destroyed as well, right? So this is called activity scoping, right? But at big tech companies, life is not very simple, right? Let's say the e-commerce team is divided into two sub-teams, orders and products. So orders team probably maintains the order information of this page, and product team probably maintains the product information, right? Now, both of them don't want to run into each other's foots, right? They want to develop independently, probably don't want to have a shared state so that they don't need to update it. It becomes messy. So they will probably not be going with activity scoping. They will need something more fine-grained, which probably they will have a couple of fragments, like one for the checkout items, one for the recommended items, let's say, right? And they would probably have their own view models. And the view models will be scoped to the fragments and will only live as long as the fragment lives. So this is called fragment scoping. But again, at big tech companies, life is not that simple. So a lot of different teams would want to use the real estate to have more product lines, right? So probably ads team would want to place an ad slot somewhere, and user growth team would probably want to put like a layout to show coupons at some place, right? And team X, team Y. Like the idea is simple. Like the same real estate is probably built by more and more teams, right? So fragment scoping is probably not enough as well. We need something much more fine-grained. So today we're going to talk about that, right? So to understand why we need fine-grained scoping, maybe let's take another example. In a compose concept, in a compose context, right? Let's take another checkout screen. This is more simpler. There is 3 checked out items, and then order total, and then a place order, right? Now there's a simple gesture that if you swipe off one of the items, it probably gets removed from the screen, right? Now they would probably look something like this. There's activity, then there's fragment, there's a compose view, which is holding the actual composables, right? Now, let's say this is how the composable structure looks like. At the top, there's checkout page, probably holding a checkout view model, and for each items, there are different composables, right? But each of the composables for the items probably has their own view models. Why? It's because probably they are holding a lot of states and information which they don't want to share it or get it from somewhere else. They want to keep it simple, so they keep it at item level, right? Now, whenever these composables get executed, in Android they will find the nearest view tree, and the view tree will be able to find the nearest view model store. With the view model store, whenever these top level view model functions gets executed, the view models get stored in the nearest view model store. In our case, it is the fragment view model store. So all of the view models get stored here. But let's say the user swipes off one of the items from the screen, the item is deleted, and the composable for that item is disposed, right? But the view model is not clear now. Why? Because the view model is stored inside the fragments view model store, which again is tied to the fragment scope. That means only when the fragment is destroyed, the view model store will get cleared, and in turn the view models will also get cleared. So this is a classic example of state outliving the UI, right? Probably sounds like a memory leak, right? So we would need something more fine-grained for Compose, right? So we will see some benefits of fine-grained scoping to sum it up whatever we discussed, right? So it gives us some isolated ownership. Now, let's say multiple teams don't have to have one simple shared or umbrella state in the top level view model, and then they don't have to keep mutating that. They can have their own UI, like what Compose offers us. They can have their own state also, and also the state manager, which is the view model. So they don't need to update the common shared view model state at the very top. They don't need to do that. And also it is bounded by the lifecycle, right? Whenever the UI appears, the view model gets created and the state also gets created. And whenever it's cleared, the state also gets cleared, likewise the view model, right? So this is probably what we want, right? What if we can make the electronics item a composable scope, right? That sounds interesting. So let's imagine that this electronics item is a composable scope. Probably it will create a view model store, and when the view model top level function gets executed, the view model gets created, right? And whenever the composable gets disposed of from the memory, from the compose tree, the view model gets cleared as well. So this is what we want. So now we have imagined what this might look like. Let's probably try building a scope at the composable level, right? So we would need a couple of things. First is we want to start a scope when a composable enters the composition, and we want to end the scope when a composable leaves the composition. And third, we want to preserve the scope across configuration changes. For example, rotation, language change, and all of this. But this is more interesting, right? Like preserving concrete configuration changes, probably very interesting. We will look into that later in bit detail, right? And finally, reset the scope whenever its key changes. For example, in Compose, the whole composition tree relies on the key. So whenever a key changes, the whole composition tree gets recomposed. So we need to respect that as well, right? To build a composable level scopes, we need to know what a scope looks like, right? How an activity became a scope. Let's see the definition. So this is a definition of component activity, which basically extends activity, but also implements lifecycle owner and view model store owner, right? Lifecycle owner is going to help us create lifecycle objects to manage the UI's lifecycle. It doesn't have to be an activity. It doesn't have to be a fragment. It can be anything to manage a UI's lifecycle. That's it. Also, similar to that, view model store owner is going to help us create view model store object that is going to in turn help us create view models where we can hold the state, right? For that lifecycle that we are just talking about, right? And a composable can also become a scope when it's a lifecycle owner and a view model store owner, right? We just discussed about like the goals of it. Probably let's try building it itself in real. So for building a composable scope, let's build a scoped composable, right? So this is probably how the API would look like. So we have a composable function which is called scoped composable, which expects a key of any type, probably null, it's okay, and probably it expects a content of which is a composable lambda, right? And we also need to do a couple of things. One is create a view model store owner and remember it. We need to do the same thing for lifecycle owner and then remember it. And finally, we need to manage them for the lifecycle of the composable. Now, why this is important? Lifecycle and the configuration change are kind of trivial. So in Android, when a configuration change happens, let's say in the context of fragment, it goes through the following cycle, right? Life cycle. First, the activity is passed, a fragment is passed, then it's stopped, then it's destroyed, and then it gets recreated with the saved state bundle. We need to do the same thing for the composable scope as well. Otherwise, it's not useful. If you lose the view model store or the view models that we created, whenever the composable is disposed of, we are losing the context, right? So we need to do that. And finally, we need to provide it to local composition so that whoever is looking for the local lifecycle owner and the nearest view model store owner, they can get this and they can get used to that, right? And this is probably how the function would be implemented. We're going to create a vModel store owner, lifecycle owner, and we have to provide it to a local composition local provider, but we don't know how we are going to create and manage it, right? Let's take a look at how we're going to do that. So first one is creating vModel store owner. So for creating vModel store owner, let's say a composable is entering the composition. We are going to create a vModel store owner object, and we are going to remember that, right? So that we can get it whenever recomposition happens, we can always get it, right? And in turn, we're going to create a vModel store object, right? And we are going to, when a composable is removed from the composition, we are going to remove the VM store. Again, it's not very simple because a composition can get disposed of temporarily. For example, when a screen orientation changes. So what happens is, when a fragment gets executed, it goes through a life cycle. When a composition tree gets a configuration change event, it is going to be completely cleared off from memory and it's going to be recomputed. So all the state is fresh, right? But we don't want that. We want to keep the information of the scope. So we need to do that. But how are we going to know whether a composable is disposing temporarily or it's disposing permanently? We can get that information with a couple of hacks, right? Let's say a composable is removed from the composition. We can check whether the parent is resumed or not. Like why we are talking about its parent. In our context, the nearest parent was the fragment, right? The hint here is, let's say a user is using a screen and the screen is built with Compose, and the screen is, he clicked on a button and it changed to a different screen, and the current screen is of scoped composable. When it moved to the new screen, that means that the new screen the change is made by the user. It was not due to any other recomposition, or it did not get cleared off from memory, right? So with this simple hint, we can think that, okay, when the mobile is visible, when the activity is resumed or the nearest parent is resumed, we can think of that the composable is permanently disposed. And otherwise, we can wait till the resume happens. And when it gets resumed, we can basically check whether the composable is re-added, right? So now, basically what happens is, let's say another example that the user is using his or her mobile and clicked on a button and probably put their mobile in the pocket. Now, there is a progress, let's say an order place button. The user pressed an order place button and the order in progress screen is shown. They put their mobile in the pocket. In the background, it moved to the order successful page, right? Now, it is again a valid case. The composable did not get disposed of for temporary reason. The order in progress page disposed of permanently. So in that case, we can think that if it is not added again when it gets resumed, we can assume that, okay, it's permanently disposed, right? And if it is re-added again, we can think that, okay, it's probably disposed temporarily. When would that happen? When the configuration change happens. When the configuration change happens, the composable gets destroyed and recreated, the same composable, right? So this is how we are going to know whether a composable gets destroyed permanently or temporarily. So with that logic, we can simply apply it in our existing case. So whenever a composable gets removed from the composition, we're going to simply check if it is temporary or permanent. If it is temporary, we're going to simply not clear the view model store because we need that view model store at this point. If it is permanent, we're going to clear that view model store, right? So likewise, we want to see how we are going to create lifecycle owner and how to manage that, right? So basically, in Compose, we often, or in any Android composable, someone wants to listen to lifecycle events to make certain decisions. Okay, in resume, they want to maybe listen to the mic. In stop, they want to stop listening to the mic, right? So we want to have a similar behavior for the scope to composable as well. We want to mimic that behavior. So how we are going to do that? Because Compose does not have any of these lifecycle events. How are we going to mimic that behavior, right? So by simply having an understanding that when this situation happens, probably it's created. So for created for a composable can be assumed that whenever remember observer dot on remembered function gets called, we can subscribe to that for a composable. When that gets called, we know that the composable is entered the composition. That means it's probably a create event, right? And for resumed, we can assume the same event because in Compose there is no resume state again. But in recent version of Android 1.8.2, I guess, where you can listen for visibility modifiers, where you can basically subscribe to on first visible. That basically says the composable is being visible for the first time. Let's say you have an example of lazy column or lazy row, where composable gets created way before it's visible on the screen. So whenever you swipe, probably it's not shown at that point. The composable is not visible at that point. So we cannot simply assume it's resumed. So in the latest versions, we can do a better job, probably, right? And the next one is we're gonna check whether the parent is paused or not for the paused event. Right? Let's say the fragment is the parent. If that is on the background, that we can simply assume that the composable is also paused as well, right? And finally, the destroyed event. So whenever we can listen for the on forgotten event, when that happens, we can simply assume that the composable is disposed as well, right? So by this, the whoever is subscribing to these events are down the line, they can know that they have whatever the events they want to propagate and then take some side effects, they can do that, right? So we were thinking of how to, we were just virtually thinking of how to make electronics item were composable, right? Let's just make it a reality, right? So let's say this is the electronics item composable, right? For now, let's just move the view model creation inside the function body. Okay, so why we are doing it, probably we'll explain it later, right? And we will simply wrap the function body with the scope composable, and now the electronics item composable or its function body became a scope. And whatever we discussed so far is applicable for the function body now, right? Now, when this view model call happens, it's going to get stored in this scope's view model store and not in a parent anywhere else, right? And but we need to know that what if my composable is disposing temporarily? Uh, Basically, whenever a composable gets disposed temporarily, we're going to lose the reference to the view model store owner from the local composition. Local composition is completely cleared off. It's going to be rebuilt again. So it's going to be completely removed from memory. So we need to keep the reference at some place, right? So how are we going to do that? We need to preserve the view model's information temporarily at some place, right? So we often have come into similar situations where when a screen orientation change happens, keyboard availability happens, and also language change happens, the configuration change event happens, and the state is destroyed. And we often use view model to solve this behavior because view model is the one is going to be surviving the configuration change outside of the UI's like normal life cycle, like destroyed or create or anything, right? So we're going to do the same thing. We're going to simply create a scope container view model, and we're going to keep it inside the nearest parent's view model store so that it doesn't get, we don't lose the reference from the local composition context, right? And we simply move our scope and the view model store reference inside that. And whenever the fragment is permanently destroyed, we can simply clear off the scope VM. That in turn will clear off the electronics item VM store and also the electronics view model as well. Similarly, whenever a scoped composable is removed permanently from the memory, we can assume that okay, probably we don't need it anymore. We can simply clear it off, right? So now that we know the benefits of fine-grained composable scoping, let's dive into how are we going to like tying this with UI and data lifecycles at the compilation stage, right? What if we had a question that with all the benefits of scope, how we can make it simpler for the developers to access, right? Let's say this is the composable function that we want to make it a scope. We just made it, but what if there are tens of composables that we want to make it a scope? Probably much more complex. Probably it's not that difficult, but for the developers, it's probably much more easier to simply annotate with a scope. Now this became a scoped composable by simply annotating, and we can simply create a Kotlin compiler plugin to process this annotation and look for a composable function which is annotated with scope, and we can simply wrap the function body with scope composable with the unit. But why we are doing it with the unit? Because before we need a runtime variable of item.id. We wanted to make it unique. Right now, probably it's not very unique because unit, but we can make it unique by simply using the current composite key hash, which is basically a key hash which is part of the binary or the APK bytecode, where it is stored as part of the compose lowering, and we can get that, and it is also compounded for the composition trees based on the location. So it is always unique. Again, not all the cases. For example, in for loops, it's not unique unless you used a keyed reference. It's not unique, but otherwise it's always unique, right? And if you just go back, we were we moved the view model creation from the parameter to the function body, right? Why did we do that? This is to accommodate creating scope within the same composable function. Again, very big. Maybe let's take an example, right? So let's say this is the electronics item which is scoped. Now this function gets called from another function called item renderer, right? Now whenever a KCP transform happens, we will wrap the function body, right? Now the view model creation is actually living outside of the scope. It is not living inside of the scope, right? And we have two options to solve it. One is we modify the function signature. We can see that if this is the function signature that looks like, we can move the view model creation inside the wrapped function body, right? Now the view model creation is part of the scope, and it will be created inside that scope. This is one option. And let's say if somebody is creating a view model and passing to this composable function, it is already not part of the scope. It is created outside of the scope. So that's okay. And that's what happened. And the second option is modifying the caller signature, right? Let's say this is the function, this is the electronics item we called from the item renderer. We can simply wrap it this way. We can wrap the exact calling of that function with scope composable. This is another approach, maybe much simpler, but we decided to modify the function signature instead of the calling function for two reasons, right? We chose the first option, which is to avoid the cost of finding all the callers and updating the signatures during transform. So basically, let's say a composable function like electronics item being called from 100 places. Now, if you want to update all the 100 function signature, probably that's not a good idea. Changing the function body at all the 100 places probably going to cost a lot. We don't want to do that. And also, we want to respect the caller's behavior and keep it unchanged. For example, the caller probably, if let's say we introduce a bug, we don't want the caller to get affected. We want the function that is wrapped with at scope annotation to take that effect and not the caller, right? So this is what we did. In summary, fine-grained scope lets each team make its own UI state without using an umbrella or shared state, so that they don't need to keep modifying a state which is owned by all the teams, right? They can have their own state like their own UI which Compose offers. And by making a composable scope with art scope, which makes this simple and keeps state tied to the UI's lifecycle, so that whenever a UI is started, the scope is also started and the state, and whenever its UI is destroyed, the scope also gets destroyed. Yes. This is about it. Let me know if you guys have any questions. Thank you.
So I was wondering, like the way that I think about UI, like most things are not atomic; they relate to each other. So I was just wondering, like how often do you run into the problem where you need things in different scopes to talk to each other, and does that lead to having to have like maintain a larger scope? And do you, like if you have
It's a-
enough of those problems, do you just
Right.
end up in the original situation?
So TikTok, in TikTok scale, probably. Can you hear me? Okay.
Oh, well, maybe not everyone. Yeah,
Okay. No, can you hear me now? No.
it's not coming through the
Mic,
speaker, I
right? Yeah,
think.
yeah,
Yeah.
yeah. Hello. Hello. Okay. Got it. So basically, even TikTok has the same problem, right? Of course, in a large magnitude, like we would have to manage states, and different teams would want to have their own state. They probably want to bring their global state somewhere. So what we ideally did is, instead of vertical state maintenance, we built our own horizontal state maintenance that lives near to their closest scope somehow. Like someone can hoist a state, like not a composed state, like not really a composed state, like a state that lives outside of the composable, for example, a view model state or anything, that can host the state, and they can speak to their neighbors, their siblings, and also their childs, so that it's not always a vertical thing that you need to maintain a scope. You can talk to your siblings horizontally also, so that you have to access something which is 5 levels up. So this is a problem always. It is always how you build your system, and probably this is not going to solve that entirely. So it is again probably a good design would help as well. This is not a 100% solution to that. I'm sorry. Yeah. Yeah. So
Yeah. Do you ever run into any performance issues? So, for example, you could imagine a view model that you are creating one for every item that's
Right.
scrolling on a screen, and that
Right.
item, that view model is doing some sort of initialization that's like kind of slow. Yeah. What have you encountered this? How do you deal with that?
So usually what happens is the view models, we don't have like hundreds of scopes at one page. So there is no hundreds of view models at one point, right? But in TikTok, there is a lot of view models that get created, and also the UI probably gets removed. So we need to release the scope immediately. We don't want that view model to be living in the memory. So releasing was as important as the cost of creation. So view model creation is, I wouldn't say it's too expensive, but there is a cost. But for us, releasing is much more important, because user would want to see the next thing, and they shouldn't run into out of memory error, right? So we don't have like hundreds of scopes vertically aligned or horizontally as well. So, but there's small cost, but we think that's worth it. Yeah. Yeah.
Hi.
Sorry.
So, quick question. You mentioned temporary, your node moving temporarily out of the composition. So,
Right.
for example, when you have a lazy column
Right.
and as you're scrolling, your node moves out. So, how do you keep the state of a certain row that
Mhm.
has its own view model and it
Mhm.
goes out of composition and then comes back? What if the user interacted with it? And then, as a follow up, one issue that we had at some point is, because different types of views that you're loading have different sets of data. Some of it might load faster than others, and then that gives a really bad user experience, because you get, say, you have 5 rows, and then you get row 3 loaded way faster than row 1.
Mhm.
How do you approach that problem when you need all of your items to have an initial state, but
Mhm.
then keep their internal state based on user interaction?
That's interesting. Let me answer the first question. So basically, the question was, let's say there's a lazy column with 10 items, let's say, and only 3 items visible on the screen. And when you swipe up, probably some of the items off the screen, it is disposed of. But is it a temporary disposition? This temporary disposition, which I talked about, is probably in a configuration change context,
Yeah.
where we are losing the context of everything. But when a composable moves out of the screen, it is up to you to decide whether do you want to keep the state in memory for that composable, for that view model, or for that item like that you want to display. That means you probably have to move the states which you want to keep it outside of that, right? But ideally, the scope composable is created so that to manage everything automatically. Okay, a composable is getting removed from memory,
Yeah.
right, from the composition tree. But you don't want to handle the removal or clearing the state. So we built this for automatic disposal. But this is not the temporary disposal. We kind of really like we don't want to solve that problem, because it's an architectural design. You want to put your state outside the items state, right? It's probably a global state you want to maintain, right? Your second question, sorry, could you please repeat? I'm lost.
That was because you have the nature of list. You can have multiple types of items.
Right.
Ones might load a lot faster than others.
Right.
So showing like the UI waiting for all items to be loaded and coordinating that they need to be shown at the same time rather than as they get their data.
Okay, so in this case, how I see it is uh, probably you may want to move that the the common state outside this thing. Maybe I'm not sure about the exact use case. Maybe we can discuss in detail. But if you think that it should be a synchronization across all the view models that's going to get created, probably that logic should live outside is what I think. But I understand compose does not guarantee that the fourth composable will be created in order. Like probably that gets created at first, right? So yeah, maybe we can discuss in detail what is the exact use case that you have. Maybe we may have solved it, or we may learn from you. Yeah, definitely. Thank you.
I think you mentioned that you're more interested in releasing.
Yeah.
So I was just curious, like, did you do any kind of like studies into before and after this approach, like how the memory management improved?
So basically, at TikTok, we do this before the compose introduce itself. So we do it, but it's all like a thing which you have to manually do it. Like in some situations, let's say you are in the create page and and it's resource intensive. You may want to release all the other resources. We manually used to do that. Right now, with Composable, we want to kind of automate that. So we didn't really do a testing for this one. Probably when we do it, maybe we can release some stats for this. Yeah.
Thank you.
Yeah. Thank you. Does anyone else has a questions? Okay. Thank you so much for joining.